Okay, now that we understand that there are these kinds of radioactive decay and we have symbols for what is an alpha particle, we have a symbol for what is a beta particle, and we have a symbol for gamma radiation, we have to be able to write equations that show the radioactive decay. And so what we're going to do is we're going to start with this first one. We're going to write an equation for what happens when uranium-238 over 92, so remember 238 is the number of things in the nucleus, that's the mass number, 92 is the atomic number, and it's going to give off an alpha particle in its radioactive decay. And we want to know what is the new nucleus that's going to be there. So the way we do this is we're going to copy the symbol for the atom that we have. So the isotope that we have is uranium-238. So we've got 238, and then our atomic number is 92, and it's uranium, okay? And so what we're going to do is we're going to put an arrow, because what we're going to say next is we're going to show what do we have left after this radioactive decay. Well, according to what they tell us, we know it's going to give off an alpha particle. So one of the things that we have after the arrow is going to be this alpha particle. So we're going to look up, and yes, we're unfamiliar with these symbols, but if they tell us alpha particle, we're going to have an alpha particle. We're going to go ahead and look up and grab that symbol, and we're going to put that in. And then we're going to put a plus sign, because we're going to have something else too. What we're going to have now is the new nucleus. Okay, sometimes they call it a daughter, but it's going to be the new nucleus. And what's going to be certain is that when we get the sum of these mass numbers, the sum of the mass numbers on the right side of this equation is going to equal 238. And the sum of the atomic numbers on the right side of the equation is going to be equal to 92. So we look at this, and we need a number that if we add 4 back to it is going to be 238. 238 minus 4 is 234. And then again here, we need the same thing. We need the number that when we add the 2 to it, it would be equal to 92. 92 minus 2 gives us 90. Okay, so this is our mass number and our atomic number of the daughter nucleus, or the new nucleus that's being formed in this radiation. We don't know what that is, but we can look that up. So we're going to get our periodic table, and we're going to look for number 90, and there it is, okay? So our new nucleus is going to be thorium. So we're going to put the symbol there. And we have it. We've made that equation, okay? Let's try the next one. We have carbon-14, and it has a symbol of 14 as our mass number, and 6 is the atomic number of carbon. Okay, and we're going to put our arrow, which is not a very good arrow. Turn my paper so I can write. Okay, not much better, but. So what is the new nucleus? Well, what they're telling us is that this is going to be beta particle. We're losing a beta particle. And I know until today we didn't know anything about what that was, but we wrote this down. And we have the symbol for a beta particle, and we can write that in. So we're going to take the symbol for the beta particle, and we're going to put a 0 and a -1 and an E for the electron. So that is our beta particle. And now we have to figure out what's left, okay? So we need a number so that when we add 0 to it, it's 14. And that, of course, is going to be 14. We need a number so that when we add the -1 to that, we're going to have 6. So something plus -1 is going to be 6. That number is 7, because 7 plus a -1 means we're going to subtract, and we would get 6. So we have 14 over 7, and now we're going to look at our periodic table. And with an atomic number of 7, we have nitrogen. So we're going to put the N in. Okay, so again, this is like a lot like when we talk about the law of conservation of matter when we're going to be doing regular equations. Remember, none of this is a regular chemical reaction. These are things that are happening in the nucleus, so these are called nuclear reactions. They're not the same as when we see a color change or formation of a gas or the formation of a precipitate. This is all happening in the nucleus, and the electrons are not involved. So these are unique, and this is how we describe what's happening in symbols so that we can talk about these processes in a symbolic form. Let's look at the last one. So this time we have carbon 14, okay? So we're gonna write that down. We have 14/6 and our symbol for carbon, and we're gonna put our arrow because we're gonna wanna show what happens when it gives off gamma radiation. So we're going to go up here and we have this symbol that's given to us of gamma radiation, and that is the Greek letter gamma, which is kind of like a, it looks kind of like a Y, but it's not really a Y. It's slightly different. Sometimes it's a challenge to get used to making a different alphabet letter that we are not used to. But we know that we have 0/0, so we're going to put the 0/0 there, okay? And then we're going to put in our gamma sign as best as we can. It's kind of like a Y. Okay. Has a little curve there. Okay. And so then what else do we get? Well, we need a number that when we add 0 to it is going to be 14. We need a number that when we add 6 to it, it's going to be 6. I'm sorry, I said that wrong. We need a number that when we add 0 to it, it's going to be 6, and that's going to be 6. And so then we have carbon. We haven't changed our identity of our atom. Okay? So that is our first 3 examples of what equations for nuclear reactions look like. And they're really quite intimidating because of all these symbols. But if we've learned what we need to know, mass number over atomic number, and we have our symbols in front of us for the radiation, we're simply starting with our starting point, showing what they tell us. They tell us alpha particle is occurring. If alpha decay is occurring, then we know we're going to have this alpha particle. We write it in. And then we simply make sure that on the right hand of our equation, when we add up the mass numbers, it's equal to our starter, which is on the left hand of the equation. We make sure that the mass numbers, when we add them, is equal to the one on the left side of the equation. And then we make sure that our atomic numbers, 90 plus 2 is 92. And that is how we write equations for radioactive decay.